All right, let's begin. I've got it on. Just move over a little bit. You know? It's okay. You're fine. Okay, now, guys, this is all you have to do. You ready? So you make it, so you divide it in half. Okay? And then you divide it in about half again, but not quite. Okay? And then this is 4 and this is 5. Right? So this is going to be 1, 2, 3, 4. And this will be 1, 2, 3. And then divide it in half, but not really, like this one. This will be 4. 1, 2, 3. 1, 2, 3, 4. Okay? So there are your columns. Okay? It should be 18 columns. Right? It doesn't have to be perfect. It doesn't have to be pretty. It just has to have 18 columns. I know, I used to be better at this, but my shoulder hurts so badly, so. But you just have to have 18 columns. Okay? Does not have to be pretty. Okay? This is the ugliest periodic table on record. Okay, so again, it's going to be nine rows. So let's say half, not quite. All right, we'll say that. Okay, and then 1, 2, 3. Okay, you get it? Right? And then 1, 2, 3, 4. Okay? You get it? Doesn't have to be perfect. The first time you do this, you're going to completely mess it up. And it's okay. But once you do it, it's going to be fairly easy. Okay? Now that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you want to number these top rows. Okay, you number the top rows. Right? Now, this is what you do. You ready? You label the side rows, only down to 7. 1, 2, 3, 4, 5, 6, 7. Okay? Now. You look at these, you put 2 dots above those rows, and you put a dot above the last 6. Okay? You get it? Good? Yes? Okay. And then, so you see these here go like this. This is what I do. I go like this. Okay? I go like this. Okay? Get it? Now, if you take out your book and open up to the back cover, I guess it's not in this book. I guess it's not. Thought it would be. I guess they never copied it. They never copied it. They never copied it. All right, so never mind. So, now the periodic table. What's the problem?
You're asking whether it's science or math.
Whether what science or math?
Are you teaching science or math?
What do you think?
I don't know.
What do you think I'm teaching?
I know it's chemistry. Yeah, I know.
Okay. So, the periodic table looks like this. This we know is hydrogen, and this is helium. Okay? And that's it in the top row. Okay? So you can get rid of, you can shade. I want you to shade. you can shade these spaces here. Okay? You know, you can't erase them obviously, but you can shade them. So shade the top row, shade the blocks 2 to 17. 2 to 17. Okay? Okay? Good? Now, we know that this is going to be BE. I'm sorry, this is going to be LI, and that's BE. Right? Now, there's nothing here until we get to what? Anybody know? Until we get to what? So this is going to be, what is number, this is going to be 1, this is going to be 1, 2, 3, 4. Okay? And then there's going to be nothing until we get here. And that's going to be boron. Okay? So there's nothing in between here. Okay? I'm going to show you, so you don't have to memorize a lot, but you have to know certain things. So memorization is not terrible. But it is the beginning of learning. If you don't know anything, you can't think about it. Okay? I'm not going to ask you to memorize enormous quantities, but you have to know how to use the periodic table. So there's certain things about the periodic table that you have to remember. Instead of saying memorization, there's certain things you have to remember about the periodic table to help you. Because the periodic table contains all the information. You'll always be able to use the periodic table in every test but the first. Yeah, because the first test is going to be on the periodic table. So you have to know, so you're going to have to be able to draw one and put certain things in. Yeah? Okay? So then we know that this is going to be, this is 1, this is 2, 2 is helium, 3, and what number's under here? 11. Yeah, 3 plus 8, you get another period. Okay? This is going to be what? Mg, right? And then we also know there's nothing here until we get to aluminum. Okay? So there's nothing in here. There's nothing here. Okay? There's nothing there. Excuse me? There's nothing there. There's nothing. It's a long story. So there's nothing there. You've heard the story before. You've heard the story before, but I'm not going to. I want to tell you very slowly. Okay, I'm keeping you in suspense. Or as they say, when the plot is about to thicken, the plot is about to thicken. Okay. Okay. Now. Then we know that this is 11. Over here, this is neon. This is 10. This is 2. What's underneath neon? Anybody know?
Helium.
What did you say? Argon. Yeah, very good. Argon. Yeah, go girl. What? Krypton, and underneath krypton? Xe. I'll take that. Xe.
What is he?
X is pronounced Z.
Xenon.
Xenon. Okay? And underneath xenon?
Rn.
The argon is here, dude.
Rn.
Rn. That's right. Radon.
Radon.
Yeah. Radon.
Bhai, we'll both again
In New Jersey, where I live, you have to, before you can sell your house, you have to get the basement tested for radon gas. Radioactive, cancer-causing, causes lung problems, very heavy. If you take a balloon and fill it with radon and drop it, it'll drop like a rock. Yeah, it drops. It's amazing, really.
So
Yeah, I have a video that will show you that.
So how do you have radon in your basement then?
Radon comes from rock.
So it's like the basement is filled with rock.
Well, yeah, it's filled with dirt
Then
and
you
rocks.
cannot get inside the basement.
Well, no, the walls are made of concrete, and then the earth is made of rock, soil is made of rock. And there's a reason why radon gas is produced. You have to know the periodic table a little bit better. All right? So these are very important. These are very important. These gas, this is very important. Okay, very important. Now, so this is going to be 11. This is going to be 3. That's 1, 4, 12. What's over here? Does anybody remember?
Yes, sir.
Whoa, girl, yeah.
Wake up.
Potassium. What's next to potassium?
I don't know, sir.
I'll give you a hint. Bone.
Calcium.
Calcium. What is bone made of?
Calcium.
No.
Bone marrow. Made of bone marrow. Bone marrow.
Yeah.
Yes, it's made of
Bone is the bone marrow is hard.
Calcium phosphate. Bone is made of calcium phosphate. That's what bone is. Okay? Now, there's 20. So now, you have these guys. These are called
Yeah, transition elements.
That's right. Transition elements. And we're gonna kind of do this more tomorrow as well. Now, right? You with me so far?
Yes, sir.
You with me so far? Now, you remember that these are the noble gases, correct?
Yes, sir.
Okay? They're inert, right?
Other
You remember that? Inert gases.
other elements want to be like
Right? Yes or no?
Yeah.
They're noble. They call them noble gases.
Noble gases.
They're inert gases, yes?
Yes, sir.
Yeah, you're gonna put the phone away, right? Doesn't matter what country you're in, cell phones are a problem. Okay? So, put the phone away, thank you. So, this is one of the magic keys of the kingdom of chemistry. I'm going to put together some of the material that you've learned over the years, and you've never been really told anything. Right, Roanoke, you with me?
Yeah.
Excellent. Yeah. Okay. Okay, absolutely. Okay. Then everything on this periodic table, chemically reacts for one reason and one reason only. One reason and one reason only. Can you gentlemen try to remember I'm making a video? I just want to let you know that, okay? Just try to remember that. Excellent. Thank you for your cooperation. I appreciate it. They react for one reason and one reason only. To be just like the nearest noble gas. That's it. You see, every chemical reacts with either itself or another chemical in order to be like the nearest noble gas. Because the noble gases are those elements that define stability. And everything in the universe seeks to be stable. And stability is based on two things and only two things. The first thing is what we're going to spend the next 8 weeks on. And that is reduction of energy. Reduction of energy.
exothermic reaction in the
Reduction of energy. And then the other thing is to increase disorder. Believe it or not, a driving force in nature is to increase disorder. Disorder is normal. It's not just something rotting or something getting old. It's not just things becoming messy. It is one of two driving forces in nature. It is a normal thing in order to become disorganized. Let me ask you a question. If I think, just think, do like what Einstein would call a thought experiment. I'm going to take a stack of small squares, perfect squares, paper, maybe 200, right? Like this thick, right? This thick of 200 small squares, okay? Now I'm going to take those small squares and I'm going to just go like this. Are you ready? Right here, right now, I'm just going to go like this. You ready? Just that's it. What's going to happen to those small squares? They're going to go everywhere. Everywhere. Okay. Right? And how much energy did I use in order to get those from a very ordered state to a very disordered state? Not much energy at all. Now think about this. I said to you, okay, fine, extra credit. Go pick up those squares. You said fine. It also took you 20 minutes in order to pick up all those squares, because you not only had to pick up the squares, you had to try to put them back in the same order in which I had them. All right. So you spent an enormous amount of energy putting them back into order. Right. So making a mess was a reaction. It was a reaction, wasn't it?
Yeah.
Something happened. Anything that's happened is a reaction. Yes or no? Physical or chemical? Yes?
Yes.
Him picking them up is a reaction. Doesn't matter if it's physical or chemistry. It's still a reaction. Yes or no?
Yes.
Okay, both happened. Okay, now, I did not put in a lot of energy to the system, did I? To make those messy. Yet it happened, didn't it? So what was the driving force of the first reaction? Was increased disorder, wasn't it? Yes? It was increased disorder, not reduction of energy. Matter of fact, I put a little energy in, but it was reduction of increased disorder. What did he do? Did he make it disordered or less disordered? He made it more ordered, right? So, but he put in a lot of energy, didn't he?
Yeah.
Both will happen. So there's only two driving forces in nature. There's a reduction
Any chemical bond
of energy and an increase in what? An increase in what? An increase in what? I said disorder, right? We're going to really talk about the reduction of energy. That's what we're really going to talk about. Now, in the reduction of energy, everything wants to be energetically stable. It wants to reduce its energy. This is what defines energy in the universe. Noble gases. Everything wants to be like a noble gas. Some noble gases can react. You can make chemicals with these three. Not many, but you can make some. These are relatively inert. Yes? But especially argon and neon and helium. They're very inert. They don't react. So, rule number one. Everything wants to be like a noble gas.
Yes, that's what I was saying.
Yes, okay. Everything wants to be like a noble gas. Okay, now. So, these are organized according to increasing number. Right? Increasing number of what? What is it increasing? Number of what? Atomic number, right?
Yeah.
Increasing atomic number. Now, what's increasing? What's the atomic number based on? The number of
Protons.
protons, right? So the number of protons are increasing.
Yeah.
Now, an atom, not an ion. What is equal to the number of protons?
Electrons.
Electrons. Yes? Okay, good. So how many electrons are in the first shell? How many electrons are in this shell? 1, 2, 3, 4, 5, 6, 7, 8. 8, right? 8, right? Remember? 2, and this. So it's 8, but I don't want to use the number 8. There's something called the octet. Well, I don't want to use that. I simply want to say, I want to say this. Can I erase some of this? I don't want to erase the table, but I want to erase some of this inside. Can I erase this? Okay, and I want to erase this. Okay, now, if lithium, sodium, potassium, any of that first row, see how I have 18 rows? Any of first row wants to be like the nearest noble gas, what is it going to do? Is it going to take on 7, or is it going to give up 1?
Give up what?
It's going to give up 1. So sodium,
Because it's easier.
sodium has 11 protons and 11 electrons. It's going to go to 11 protons and how many electrons? It's going to give up 1, 10. Right? So, what's the charge of everything in group 1 going to have when it reacts?
Negative charge.
No. What? No. How can it be a negative charge? I have 11 positive charges and 10 negative charges.
It's gonna be positive. Because
It's going to be positive. This is integers, right? So it's going to be positive 1. How about this group? How about this group? It's going to give up 2, right? So what's the charge going to be if it gives up 2?
proton.
4.
It's going to give up, how do you get 4?
Sorry, it's gonna give up 2 electrons. So
It's going to give up 2 electrons. Are the number of protons going to change?
No.
No, because the element's not changing. This isn't nuclear physics. This is simply chemistry. We're talking about the electrons. The number of protons remain constant. So, beryllium, magnesium, calcium, they give up 2 electrons. What is that entire row, the charge of anything in that row, what's it going to be? Positive what? Positive 2. Good. Positive 2. How about that? Is it going to give up 3 or is it going to take on 5?
Give up 3.
It's going to give up 3. It'll be plus 3. This will be plus 4 or minus 4. Now, let's look at number 7. What's number 7? This is calcium, this is carbon, this is nitrogen. So is nitrogen going to take on 3 or give up 7? Sorry, give up 5.
Give up 5.
No.
Really?
Take 3.
It's going to do what?
It's gonna take 3.
So what's its charge going to be?
Negative 3.
Negative 3. That whole column will be negative 3. This is phosphorus. Okay? Phosphorus. 15. Right? This one, what's that row going to be? This is oxygen.
Negative 2.
Negative 2. This is fluorine. Negative 1. Matter of fact, there's certain columns you have to know and certain rows you have to know before we do anything. This is going to be
Halogens. Something called halogen.
what's that chemical going to be there?
The cyanide.
Chlorine. What's this one going to be? Bromine. Iodine. Yes. Okay. Yes. Now, we haven't finished the periodic table yet. So we're going to work on this tomorrow, but let's finish the actual shape of the periodic table, okay? Yes? Now, 7 rows, right? 7 rows. Now, the modern periodic table, made up not Mendeleev, the modern periodic table was made by somebody called Glenn Seaborg after World War II in the late 40s, early 50s. And what he did was, he took out these two rows from these two rows. And so this has, get rid of this, get rid of this, get rid of 4 blocks, right? You get rid of 4 blocks, and this has 14 columns, 14. And it's detached. Where you guys go? Right. These are detached from the periodic table. Thank you for being quiet. I appreciate that. I'm filming. These are detached from the periodic table. Okay?
You were filming?
They're detached from the periodic table. Okay? That's the periodic table.
Yeah.
And what we'll do tomorrow is I'll finish putting up there what you'll need to know for the first. It's going to be a giant quiz where you're going to have to actually, with a ruler and a pencil, and I'm going to give you a sheet of paper, you're going to have to draw the periodic table, fill in what you need to fill in. Understood?
Everything?
I'm going to no, not the whole periodic table, no. But some of it, yes. We're off.
Hey, video what is that?